Right, in this short video I'm going to show you some neutralization reactions. I'm going to show you some acid metal reactions, but the idea is I want to show you how salts are produced when acids and alkalis behave in chemical reactions. So let's look at one we've already seen before. Let's look at the neutralization reaction between sodium hydroxide and hydrochloric acid. Okay, so let's pour a little bit hydrochloric acid. Right, universal indicator. What colour is this going to go? In hydrochloric acid. Right, no prizes for guessing that that's going a nice orange colour. Okay. Right, now if I slowly add the sodium hydroxide, that's going to neutralize the hydrochloric acid. Okay. Still an excess of hydrochloric acid, so I need to keep going with, almost there. I need to keep going with the sodium hydroxide. Right. Almost there. So have I gone too far? Yes, I've now gone too far with the sodium hydroxide. So I need to go back again with the hydrochloric acid, but I've not gone too far past it. So what am I after? I'm after a neutral solution, which, if you remember, what colour is that? The neutral solution should be green, so we're very close. Yellow, as you remember, is a pH that's very close to 7. Okay. So it's almost there, isn't it? I reckon one more drop. There we have it, green. So that's now a neutral solution. Okay, but what is in that solution? So all of the sodium, all of the hydrochloric acid and all of the sodium hydroxide has reacted together. Now, if you remember from last lesson, the products of these two neutralizing are sodium chloride plus water. So this should be just sodium chloride dissolved in water. Now, if I was to evaporate the water off, that would leave me with salt. Okay, the same table salt that we put in our food. The only issue is it would be green because we've got the universal indicator as well. Okay, right, let's look at another reaction. Okay, it's another neutralization reaction. Right, now this time I'm going to use sulfuric acid. Okay, if you remember sulfuric acid, what does that produce? Sulfuric acid, what types of salts do they produce? Sulfuric acid produce sulfates. Right, now I'm not going to use an alkaline, I'm going to use a base, an insoluble base. Okay, so that's going to neutralize the sulfuric acid. Okay, and the copper oxide is a black powder. Hope you can see that there. That's the colour of the copper oxide. Now if I pour and mix in, okay, the black copper oxide, let's go big with the sulfuric acid. Now if I give that a good stir, right, now we've definitely got now an excess it looks like, of the copper oxide. Now if I filter this, okay, what colour is the sulfuric acid? So the sulfuric acid is colourless. But if I filter this with a filter funnel into a test tube and filter paper, okay, I'm after the solution that's being produced here. More importantly, I'm after what colour it is. Okay. Right. What colour is the solution that's being produced here? Well, hopefully you can see there that it's a blue solution. So we started with the colourless sulfuric acid. We had the black powder, which is copper oxide. But one of our products is a blue solution. Now this blue solution is, so see if we can guess. We've got copper oxide and sulfuric acid. So as you know, sulfuric acid produces sulfates. So this blue solution is a solution of copper sulfate. Okay. Another neutralization reaction. Right, last one I want to show you is not a neutralization reaction. I want to show you a reaction between an acid and a metal. Okay, so I'm going to go big with the sulfuric acid again. Now, the metal I'm going to use, the metal I'm going to react with is magnesium. Okay, so the magnesium is going to go in here. Right, now one thing, I want to collect the gas that's being produced here. Okay, so we use a filter funnel. Now the reason is, the gas is hydrogen gas. And the way we can test that is with the famous Squeaky Pop Test. So let's have a go. So magnesium powder, this says magnesium powder, this is little turnings of magnesium. Okay, so let's see how vigorously this reacts. So as you can see there, bubbling away. Now the reason it's bubbling away is because there's a chemical reaction taking place. Now that chemical reaction is producing hydrogen gas and a salt. Right, let's collect that hydrogen gas. Like so. So as you can see, now there's a lot of heat being given off as well, but as we can see it's bubbling away, and I'm collecting the hydrogen gas in the test tube. Okay, so that's quite hot. It's bubbling away and producing hydrogen gas. The hydrogen gas is being collected in the test tube. Now, this is the famous Squeaky Pop Test. Move that to one side. Right, I need a flame that doesn't blow out. I need a flame from a match that doesn't blow out. Right, are you ready? So that's the famous Squeaky Pop Test, proving that that gas that was produced in this reaction was hydrogen gas. Now one last thing. We've got hydrogen gas, but what's the salt that's produced? Okay, what's the salt that's produced? Well, here's a clue. We reacted magnesium with sulfuric acid. So the salt that was produced was magnesium sulfate. So we've got magnesium sulfates plus lots of hydrogen gas. Okay, thank you.